Welcome everyone, I'm Shashank at AWS, and in this webinar today we'll be talking about scaling machine learning on Kubernetes and Kubeflow with Amazon SageMaker. This will be a fairly introductory webinar, so I'll introduce all of these services and concepts as we go along. But of course, if you're an existing user of Kubernetes or are considering using Kubernetes, you'll get the most out of this webinar. So here's how we'll spend the next 30 to 40 minutes. I'll start off by talking about some of the key challenges with scaling machine learning, and then we'll take a look at some of the services and tools available to you that lets you scale machine learning workloads on a cluster. And particularly, we'll take a closer look at Amazon SageMaker, Kubernetes, and Kubeflow, which are some of the most popular services out there that let you do this. We'll then take a look at how you can use them together. There are some things that are easier and nicer to use in Amazon SageMaker, and Kubernetes and Kubeflow is great for a few other things. We'll take a look at how you can leverage some of the capabilities in Amazon SageMaker while staying within your Kubernetes and Kubeflow environment. There are two ways to do this. The first is by using Amazon SageMaker components for Kubeflow pipelines, and the other is to use the Amazon SageMaker operators for Kubernetes. If you don't know what operators and components are, that's totally fine. We'll introduce them and we'll see plenty of demos, so everything will get clearer. And finally, in addition to demos, we'll finally wrap everything up with some summary, Q&A. I'll also share some references that you can use to get started right away after watching this webinar. So let's get started. If you're a developer or a data scientist, you may have started developing your machine learning algorithms on your laptop or desktop, or eventually started doing your training and prototyping on an Amazon EC2 instance, and you're really looking for four key ingredients. One, you want compute, you want CPUs and GPUs where you run these algorithms on. You of course want storage because you have training data sets, but also metadata that you generate during training. You of course want source control if you want to track progress and collaborate on your code. You also want access to machine learning frameworks that you use to train and deploy your models. But as you start thinking about operationalizing your workflow and collaborating and running large-scale experimentations and distributed training, you want to start using a cluster. And this is easier said than done because the usage paradigm changes when you go from a single user, single machine to single user, multiple instances in the cloud. The key challenges are scaling, managing this infrastructure. As a researcher or a developer or a data scientist, you may or may not be an expert in managing infrastructure. And most machine learning workflows are actually multi-step workflows. It's not just training a model or deploying a model. You'll have data cleaning, data manipulation, transformations, running hyperparameter optimizations, then large-scale distributed trainings, model validations. It's a multi-step workflow, and often with many steps that require you to go back to a previous step and so on. So these pipelines are complex, and being able to do this on a cluster can be challenging. And if you look at the landscape of tools and services available to you, fundamentally, there are compute instances. These are your same EC2 instances that you use and love to run your machine learning workflows. You can set up a cluster on these instances on your own if you have the know-how and expertise and you need that level of flexibility. But over the years, services such as Amazon ECS and Amazon EKS, which is a managed Kubernetes on AWS, let you abstract away all the cluster management capabilities so you can focus on the applications and deploying your applications. And these are primarily container orchestration services. So they expect that your applications are containerized, and in order to manage these containers, you can use a container registry such as Amazon ECR, where you push your containers to that are later pulled and scheduled on and clusters, say, managed by Kubernetes. Now, everything I've shown here has nothing to do specifically with machine learning, but they let you scale workloads on a cluster. Of course, the Kubeflow you see here is specific to machine learning, but we'll get to that in a minute. So other than that, everything here is pretty generic. Now, once you start entering domain-specific services such as machine learning, there are capabilities that you will need above and beyond basic infrastructure capabilities. And Amazon SageMaker is a service that has capabilities for end-to-end machine learning workflows, everything from hosted Jupyter Notebook instances to fully managed training clusters. You can do distributed training, large-scale hyperparameter model tuning workflows. All of the infrastructure is fully managed for you. You have one-click deployment, so hosting a model is as easy as a couple of lines of code, and you don't have to worry about load balancing traffic and doing A/B tests. All those capabilities are built in, and the whole idea is to give you a fully managed experience when scaling machine learning workflows on a cluster. So great. So this is what the landscape looks like today. And in this webinar today, I'll focus specifically on these two bullets. The first one is Kubernetes and the Kubeflow layer that sits on Kubernetes, which adds machine learning capabilities. And second, Amazon SageMaker. And particularly the focus of the talk is how you can leverage SageMaker capabilities within your Kubernetes environment. So if you're an existing Kubernetes user, or you intend to standardize on Kubernetes or want to use Kubernetes, but don't want to be left behind with some of the innovations and latest capabilities available in SageMaker, this is the webinar for you. So let's, for those that are not entirely familiar with Kubernetes, or even if you're familiar with Kubernetes, let's briefly introduce how this works for machine learning, so this can serve as a quick recap. As a user, you can instruct a Kubernetes cluster of a desired state. In this case, for machine learning, it may be that you want to train a model on 2 GPUs, or you want to host a model on a Kubernetes cluster that should be backed by 10 CPU instances. So you specify this desired state declaratively in this sort of a specification file that you see here, typically written in YAML format. And then Kubernetes is responsible for taking your workload and scheduling them on the cluster. Think of this as an operating system for your cluster. So you don't necessarily specify how to do it. You just tell it what you want. So you don't specify scheduling on a specific node, for example. You just say, I want 4 GPUs, and it will go get it for you. This has been revolutionary for a lot of applications because you can really abstract away the way you think about clusters and just focus on your workflow and applications. But when it comes to machine learning, there are a couple of challenges, primarily being it's not data scientist friendly because if you're a user of Kubernetes, you expect to write your jobs in a YAML spec, which data scientists prefer doing in languages like Python. And by default, Kubernetes is more of a fundamental container orchestration technology. So there aren't many machine learning specific capabilities such as experiment tracking and workflow management. And with Amazon EKS, you get a fully managed Kubernetes experience. The control plane is managed for you, but you're still responsible for managing the workers by specifying how many nodes you want in a cluster, how many GPUs do you want in a cluster. If you need more capacity, increasing them and decreasing them and so on. So you're still responsible for those things. And the community saw the need for machine learning capabilities on top of Kubernetes, and this is how the Kubeflow project was born. And Kubeflow is a layer that sits on top of Kubernetes and offers many of the things that you want as a data scientist or a machine learning developer, particularly a model development environment with Jupyter, data preparation with, say, integration with Apache Spark, training with a multitude of frameworks, model tracking, experimentation tracking, pipelines for managing multi-step workflows, model deployment with things like Selden Core, TF serving, and hyperparameter optimizations with Katib, This is not an exhaustive list. There are other capabilities like Kubeflow pairing that lets you take your training from your local machine to Kubernetes. So there are a lot of these capabilities that the community has developed in order to make it machine learning friendly. But fundamentally, Kubeflow still relies on Kubernetes to manage the infrastructure, which means it relies on you to manage the data plane, right? How many workers and so on and so forth. In contrast, Amazon SageMaker is a fully managed service for machine learning. It has capabilities for every step of your machine learning workflow, including things like ground truth for labeling your data sets. You can get public access to Amazon Mechanical Turk or private workforces who can label your data sets. Provides a full-featured IDE for model development and prototyping with SageMaker Studio. You also have AutoML capabilities with SageMaker Autopilot, experiment tracking, SageMaker debugger, fully managed training infrastructure, which means if you have if you want to burst capacity, you can simply specify how much capacity you want. SageMaker will automatically provision for you, execute your training or deployments, and then it'll shut it down. So it's fully managed in that sense. There's also automatic model tuning, cross compilation with SageMaker Neo, and so on. Again, this is not an exhaustive list. There are other capabilities like SageMaker processing, and everything with SageMaker is geared towards a developer or a data scientist. So there are these capabilities that are constantly being developed and enhanced to help a data scientist be more productive and not have to worry about infrastructure at all. So this is great, and I use this every day, and there are nice APIs that you can use to be productive with machine learning. Now, when you talk about scaling machine learning on Kubernetes, you can actually leverage some of these innovations that are in Amazon SageMaker. So if you're a current user of Kubernetes and Kubeflow, are planning to use Kubernetes and Kubeflow because for various reasons you want to use a shared infrastructure in your organization where other teams rely on Kubernetes for critical aspects of their workflows, or you want capabilities in Kubeflow such as repeatable pipelines, you have automation that's already set up around Kubernetes, maybe you have CI/CD pipelines already set up around Kubernetes, you want to use something that's open source. So there may be a multitude of reasons why you've standardized on Kubernetes and Kubeflow. At the same time, you do want to leverage some of the innovations in SageMaker, particularly fully managed infrastructure. Say you want burst capacity, you want 128 GPUs for a distributed training run, you can get burst capacity with Amazon SageMaker for spiky workloads. You want things like ground truth labeling, or you want to leverage built-in optimized algorithms in SageMaker that the SageMaker teams builds, which are multi-distributed ready and scaling ready. Another popular feature is managed spot training. If you don't want to manage spot instances, but you want to get up to 90% savings, SageMaker has built-in capabilities for these things, one-click deploy with scalable inference endpoints, and many more. So there are these capabilities that you may want to use along with your Kubernetes and Kubeflow setup. And you can do that today, and I'll show you two different ways to do that. The first way to do that is if you're a Kubeflow user, you have your machine learning teams already using Kubeflow, or you're planning to set up and use Kubeflow. A new capability that AWS developed and contributed is Amazon SageMaker components for Kubeflow pipelines. I will share resources later, also getting started resources. We'll also see this in a demo. With this, you can make SageMaker, you can use SageMaker as components in your existing Kubeflow pipeline. So you can mix and match between components that you develop which run on Kubeflow and components that run on Amazon SageMaker. The second way to do this is if you're not a Kubeflow user, but you are a Kubernetes user, you're standardized on Kubernetes, you can use Amazon SageMaker operators for Kubernetes. Here you get the more native Kubernetes experience. You will write your own YAML specification files that can be versioned and be part of your CI/CD pipeline, and you can submit training jobs, host models, do hyperparameter optimizations, batch transform jobs, and others. You'll submit them to Kubernetes, but they will run on Amazon SageMaker. That way, you can stay in one environment and get all the benefits of Amazon SageMaker. If you're new to Kubeflow and pipelines, I'll do a very brief introduction. If you're already familiar, this will be a quick recap. With Kubeflow pipelines, you can design end-to-end machine learning workflows. As we mentioned, machine learning is usually a multi-step process, and there's usually more than one step to go from start to finish. By developing a pipeline where each component in a pipeline performs a specific job, it becomes very easy to manage experiments and trials. So if you want to rerun an experiment, you're not just rerunning training, but you're rerunning the entire pipeline. And these components are modular, so you can quickly change and replace and share it with others, so it's easier to run through the same workflow and get reproducibility. Now, Kubeflow pipelines can be as simple or as advanced as you feel like you need for your workflows. A quick example shows here a multi-step workflow with multiple stages in data preparation, multiple stages in model development, multiple stages in model deployment. Each of these are separate capabilities that can be a SageMaker capabilities, as we'll see in an example below. For example, you may you want to choose Amazon SageMaker hyperparameter optimization, or you want to host a model using SageMaker, but manage the entire pipeline in Kubeflow. So how do quick recap on how do pipelines work in Kubeflow? Each of these steps are called components, and typically there are multiple things in a component, but the key things to focus on is the input-output signature. So it consumes something from a previous step and produces something that the next step can consume. And then there's logic implemented in a container. And this logic container can be in a container registry such as Amazon ECR. So this makes it very modular. So you can string together multiple steps like this. Now, when you introduce SageMaker components, what changes is that each of this step, instead of having the logic in a container, what instead it can do is have the logic be executed on Amazon SageMaker. So there's a components container that will take in your description, the job description, say it's a training job or a hyperparameter optimization job, model hosting endpoint, inference endpoints, and so on. It'll then forward these requests to Amazon SageMaker, and SageMaker will do that particular step, but it's still part of your Kubeflow pipeline, so you can manage the workflow as part of Kubeflow pipeline. With that, let's take a look at a demo. In this demo, I'll build a very simple pipeline. This pipeline is 5 steps, as you can see on the right. We'll go through hyperparameter optimization. I'll specify a training script, and I'll specify the hyperparameters that I want to tune. Then this is a step that will happen in Amazon SageMaker, but it'll be in a Kubeflow pipeline. After we run the hyperparameter optimization job, what I'll do then is pick the best hyperparameters from the large number of jobs I ran. SageMaker runs for me actually, and then I'll increase the number of epochs. So I'll only run a large scale job with 10 epochs, but then I'll pick the best hyperparameters and increase the epochs to 80. That's the next step. And then I'll run a training job on the best hyperparameters for 80 epochs. And the output of that is a model that I want to create as a model artifact in SageMaker and deploy the model. So these are the 5 steps you can see here. And if you're new to SageMaker, if you've never used SageMaker, there are a couple of ways to submit jobs to SageMaker. You can, if you don't want to deal with containers, there's a way to just bring your own training scripts. So you just provide your training scripts in TensorFlow or MXNet or PyTorch or a couple of other supported frameworks, and just specify that you want to use a TensorFlow container, and SageMaker will automatically, figure out pulling the right container and running your training job. So you don't have to deal with containers at all. But if you're used to building containers and you want to build your own custom containers, you can also BYO, bring your own container and push it to Amazon ECR, and then you can have SageMaker run training using that specific container. Just before we dive into the code example, here's what happens behind the scenes. So each of these steps will spin off this SageMaker capability. So the first step will spin off a hyperparameter tuning job in SageMaker. The second step is a custom function that I'll show how we wrote. All that does is take the output of the Amazon SageMaker tuning job, increase the epochs, and then forward it to a next step, which is the actual training job, then create model and deploy endpoint. Okay, so with that introduction to this demo, let's dive deep into the code and take a look at how these pipelines work. Okay, so I'm here on my browser and I have the Amazon SageMaker Console. I just want to briefly show you some of the capabilities that are available here in SageMaker, and when you execute these SageMaker jobs via Kubeflow pipelines, they can still be monitored right here on the SageMaker console. As an example, you can see some of my recent activities here. I have some training jobs that are completed and finished. I have 2 model endpoints hosted. All of these were done through Kubeflow pipelines. So I don't have to come here, but I can get an overview of SageMaker jobs and endpoints that are hosted. You can also look at other capabilities here. So there are training jobs, inference, and other capabilities. And we'll take a look at how these jobs will appear here when you submit them through Kubeflow pipelines. So I'll head over to my Jupyter lab here. So I have a couple of examples, and I'll start with the Kubeflow pipeline example. And a few things I should mention before I go through this example. I've already set up my Kubernetes cluster. If you are new to using Amazon EKS, it's fairly easy. You just have to download the EKSCTL. Let me increase the font. EKSCTL command line tool, and with a few command line arguments, you can specify a cluster description and it'll go spin up the cluster. So I'm launching Kubernetes cluster 1.15. I have in US West 2 region, I want 2 nodes of this type of instance and so on. And it'll automatically provision a cluster for you. So pretty simple to launch a cluster, even if you're not a IT or an ops sort of a person. I am certainly not, and I find it very handy to launch Kubernetes clusters with this CLI tool. Okay, so once I have my cluster up and running, there are a couple more steps that you'll need to follow to install Kubeflow, and you can find these instructions in the actual Kubeflow documentation. So if you go to kubeflow.org/docs/AWS, this is the official Kubeflow documentation, and you'll find plenty of helpful documentation here that shows you how to install Kubeflow, but also use some of the key capabilities. Okay, so these 2 steps I'm skipping because they're not as exciting as the main topic here, which is SageMaker components for Kubeflow pipelines. So I have 2 examples here. One is to use script mode, which I mentioned, wherein you just bring in your training script and it'll automatically spin up a Kubeflow it'll automatically spin up an Amazon SageMaker training job just using your script, and you don't have to build a container or anything like that. And my code is in a code directory here. You'll see that I have a training script. I have my handler script for inference deployment, some other dependencies. Okay, so let's go through this this demo. There are 5 steps, as I mentioned, in our pipeline. So there's the hyperparameter optimization, selecting the best hyperparameters and increasing epochs, training models, creating a model artifact, and then deploying. So Kubeflow is very data scientist friendly. You don't have to write YAML scripts. You can just use their Python package with KPF. Just import Kubeflow pipelines, and then you can string together a pipeline. To use SageMaker components, you will want to load these components from URL, and these are located in GitHub. I'll open this up quickly. You'll see that there are all these components that are available that lets you do training, testing, model deployment, hyperparameter tuning, ground truth jobs, and so on. If I open up, let's say open up training, you'll find that there are specifications on what arguments you need to provide in order to run a training job in Amazon SageMaker, staying within Kubeflow pipelines. So you can load these up from URL, fairly straightforward, as I show here. And then you can string together these ops so that they form a pipeline. So a couple of other things, I get SageMaker role so that Kubeflow pipeline can actually has permissions to launch these jobs on SageMaker. I specify where my training data sets are. I expect them to be in Amazon S3. And if they aren't, you can download and upload it as I show here. And if you're using the script mode, wherein you don't want to build your own container, it's fairly simple. All you have to do is generate a tar file with your training code. So all my training code is in this code directory. I'll have to generate a tar file, tar.gz file, and just upload it to Amazon S3. And SageMaker will manage all the container aspect of it. It'll go pull the training script, pull the container, drop your training script in the container, and execute it. So as a data scientist or a developer, you just focus on your training and prototyping. Don't have to worry about containers. And then this is where the interesting part starts, which is creating a pipeline. Let me skip this custom op for a second, and it'll become relevant as we go through this pipeline. So the signature that Kubeflow expects is to put a decorator here specifying that this is a pipeline on top of your function. And here, I first specify all the arguments that are common for the steps below. So I'll be running hyperparameter optimization, model training. They all have these common parameters, like what kind of region, what kind of instance I want to run this on a GPU instance, and so on. So you specify this right up front, or you can specify them, each of them. So here are my 5 components. So I'll go through each of these components. So component 1 in my pipeline is SageMaker hyperparameter optimization component. And in this model tuning step, I specify that I want to do a Bayesian hyperparameter search. I want to maximize my validation accuracy. Here are the static parameters that don't change, but here are the things that I want you to optimize. So I want you to optimize my learning rate. I want you to optimize my optimizer type between SGD and Adam. Pick the best one. I want you to pick the best batch size, best model type, ResNet or my custom model, and so on. You can specify any options you prefer here. And after that, a couple of other things that are specified in the documentation, such as where are your training data sets, where do you want the output model to be. In this case, I want to run maximum of 16 jobs. That means I want to try 16 different combinations of these hyperparameters in order to find the best one. And you can specify that at any given time, you want to run only 4 jobs in parallel. If you have limits and capabilities, you can increase maximum jobs to say 128 jobs and run all of them in parallel. Complete flexibility. And because this is running on Amazon SageMaker, you don't have to worry about provisioning these infrastructures. So all of these jobs will automatically provision the infrastructure for you, spin up the instances, run your training, and shut it down. So completely transparent, happens behind the scenes. You can monitor them, but you don't have to know how these are done behind the scenes. And I'll show you what this looks like in a moment. So this is your first component. The output of this component can be obtained by saying hpo.outputs and best hyperparameters. If you take a look at the previous step, this is called hpo, and the output of hpo is available here, and you can then process this output. And this is where I am processing this output right at top here. So I created a custom function called update best model hyperparameters. So I take the output, and very simple function. All I'm doing is updating the epochs to 80. So when I run the hyperparameter optimization job, I just specify 10 epochs because I want to try more combinations, but only try for 10 epochs. I don't want to run all of them for 80 because they'll clearly be poor jobs that I don't want to be wasting resources on. But once I found the best model, I want to then run it on multiple epochs. So I specify 80, and Kubeflow Pipelines provides a function called func to container op. So basically it takes this function and then figures out a way to execute this in a container so that it can be part of our pipeline. So this is essentially my second component. So it takes my hyperparameter optimization outputs and then generates new hyperparameters that I can then pass to my component 3, which is my SageMaker Training op. So here again, I specify some standard things like where my data set is, where I want my output. And once that training is done, remember, these are not running right now. I'm just building the pipeline. Once that is done, I can then specify uh, tell SageMaker to create a model artifact. Once a model artifact is created, with just this few lines of code here with component 5, I can host a highly scalable, highly available model endpoint with Amazon SageMaker. It's really that simple. So with this pipeline, if I execute this pipeline, let's go ahead and run this. I've been walking through this, but not executing this. So let me quickly run this, and so I can show you what this training job looks like. So I execute my pipelines, I compile my pipeline, it compiles into a zip file, and finally I can run an experiment. So once this experiment is run, you get some links here, but I can go to the Kubeflow dashboard and I can take a look at some of the experiments. So this is a Kubeflow dashboard. This is a standard dashboard you get once you install Kubeflow. You'll see that I just submitted this to the webinars experiment, and I have two. One I ran yesterday and the one that we just started running. The pipeline, this is the first step of the pipeline. You can see that whatever I specified here, my input and output channels, the type of instance that I want to run it on, a GPU instance, and so on and so forth are specified here. You can also take a look at logs to see what's going on behind the scenes. Once the job is done, what artifacts and so on. So this is a job that's currently running. I won't make you go through watching this run. Instead, I have a job that I ran yesterday, and this is what a completed pipeline run looks like. Each of these steps here, except for the second step, is actually a SageMaker step. And let's take a look at this intermediate step. Let's see, logs, refresh. Okay, logs, and you'll see this is the hyperparameter job that was completed, and you can see input outputs. So this was the best model hyperparameters from the previous step, with my epochs changed from 10 to 80. We can also take a look at that. If you look at the second step, you'll see that this is the best hyperparameters that came out of hyperparameter optimization, and I basically switched from epoch 10 to epoch 80. And so these are your pipelines. You can take a look at them here. You can monitor them and so on. And I mentioned that each of these steps run in SageMaker, so you can also take a look at them in the SageMaker console. So if you head out to SageMaker console, you'll see here under hyperparameter tuning jobs that I currently have a tuning job in progress. I have one that I ran yesterday. So I'll open the one that I ran yesterday, you'll see these are all the hyperparameter tuning jobs that ran. You can take a look at the best training job right here. So you'll see this was the best validation accuracy out of all the models that ran, and this is the best combination. Now this was run completely on SageMaker, so you can also monitor them here. And I won't spend too much time on SageMaker because that can be its own topic. With that, I'll get back to let's get back to the presentation. So that's a quick overview of pipelines, a demo, and it's fairly easy to set up and use. So even if you have a small Kubernetes cluster but need burst capacity, you can easily ship them off to Amazon SageMaker. So that was the first demo. Let's take a look at the second approach, which is to use Amazon SageMaker operators for Kubernetes. This is for users who are not Kubeflow users, but use Kubernetes, have a lot of their machine learning set up in Kubernetes, or you want to set up a lot of your machine learning workflows on Kubernetes native. And perhaps you have help from your IT or ops team to automate some of these to make it more data scientist or developer friendly. And let's take a look at a demo on how this works. So with SageMaker operators for Kubernetes, you specify your job as in a YAML specification file, as you see on the right here. This is your native vanilla Kubernetes experience. If you like writing YAML files and this is how you've been doing this, then you'll feel right at home. You can use the kubectl, kubectl, or however you like to pronounce it, CLI tool that's part of Kubernetes to submit a variety of these types of jobs. And because these are done declaratively in a YAML specification file, they can be versioned, they can be made part of your CI/CD pipeline, and so on. So let's take a look at a demo of how this works. What I'll do is show you how to run a distributed training job. So you will write a YAML specification file. You'll use kubectl to submit a job to your Kubernetes cluster, which will in turn use the SageMaker operators to schedule the job on Amazon SageMaker. So you get this burst capacity with Amazon SageMaker, even though you may not have that capacity in your Kubernetes cluster. And because this is fully managed, you don't worry about how to spin them up and shut them down. It's fully managed. You can also leverage things like manage spot instances, spot training, so you can save a lot of money as you run training on Amazon SageMaker. Submitting a job is how you would submit anything else to Kubernetes using the kubectl apply and specify your YAML specification file. So let's take a look at a demo of how this works. I'll head on back to my Jupyter notebook and let's open up the SageMaker operators example. Again, I'm assuming that I have my Kubernetes cluster all set up and ready. If you want to verify, you can always say kubectl get nodes, right? I see that I have 2 nodes. Let me increase the font so it's easier to see. So I have 2 nodes here. So I have my Kubernetes cluster currently up and running, the same cluster I used for the previous example. And clearly, these 2 CPU nodes are not sufficient for machine learning workflows, but that's where these operators come in. You can actually submit jobs to SageMaker, so you don't have to use your Kubernetes nodes to do this. That way you can improve GPU utilization as well, because they're not running hot all the time. They are only provisioned when you need them. Let me open up this Jupyter notebook where I have a couple of steps on how to do this. And again, there are steps on how to install these SageMaker components. I'll share these documentation links with you. This is part of the SageMaker documentation. There's a description on what the operators are, how to use them, how to set them up, what kind of jobs you can run in them, and so on. Again, I've set this up already, so I won't set it up here. But once you've set them up, They're essentially, these operators are essentially custom resources. If you're familiar with what custom resources are in Kubernetes, so they extend capability of Kubernetes by adding these custom resources as operators. So they're domain specific controllers, so to say. And these are all the capabilities that you get now when you take a look at all the CRDs that are SageMaker. So you can do batch transformation jobs in SageMaker. You can host endpoints, configure endpoints. You can run hyperparameter tuning jobs. You can create model artifacts. You can run training jobs, of course. And I'll quickly run through these steps, which just make sure I have the right permissions and roles and such. And just like before, you have the option of packaging your training scripts and just uploading them to Amazon S3 and expecting SageMaker to manage all the pulling the right container and all that. Or you can build your custom container and push custom container into your registry so that you can have SageMaker run training from your custom container. In this case, I'm gonna upload my training script here. So on the left is my vanilla TensorFlow Keras training script that uses Harvard library to do distributed training. This is something you would write on your laptop or your desktop. I'm gonna upload it to Amazon S3, and you can specify a restrictive role here just to give access to SageMaker. And applying this job is easy. You just have to do kubectl. This is what it looks like. Kubectl apply -f and the name of the YAML specification file. And this is the YAML specification file. If you're an existing Kubernetes user, you're used to doing this, this should look all too familiar for you. Few fields that are specific to the SageMaker operators are, of course, the type of job, which is a training job. You can specify hyperparameters like so. You can specify your data sets, the type of where you want to run this training. In this case, I want to run it on a GPU instance. Where my data set is. My data set is in Amazon S3. I have my training data set, validation data set, eval data set, and so on. So this is your pretty standard YAML specification file, but specifying that it's a Kubernetes training job. And once I submit this job, it'll create a training job. You can run these on the terminal. I just like showing this on Jupyter notebooks. And then once I run that, I say get training job, and you'll see that I have a training job that is starting. I can query this again. It's in progress. And I can also take a look at more information about the training job. You'll see this is all the information in the YAML specification file. It's starting and it's starting to train. Great. So that's it. All you have to do is write specifications files such as this and submit your training job. I've written about how to use this in a two-part blog series, which I will also share as part of the webinar material. But to quickly show you, I go through what it is, how it works. And in the second blog post, I also provide several examples. So you don't have to start from scratch. You can take a look at these 4 use cases that I provide. One is distributed training with your training script, distributed training with your custom container, wherein you bring your own container, hyperparameter optimization, and hosting an inference endpoint. I provide the YAML scripts for all of these. They're also linked out of my GitHub repository. You'll find these YAML specification files. So you don't have to start from scratch. You can start here and customize it for your workflow and applications. Okay, so that brings us to the end of the second demo. I did mention that you can bring your own container, and I didn't demonstrate it to you, but let me quickly show you how you can bring your own container either when using SageMaker operators or when using Kubeflow Pipeline, SageMaker components for Kubeflow Pipeline. So you write a pretty typical Docker file And in this case, I write a Docker file that pulls from an existing TensorFlow container that's hosted on AWS. And I install SageMaker Training, which is a library that helps SageMaker identify this is a container meant to run SageMaker training jobs. And then I copy all my training scripts as shown here, and inference scripts or other dependencies. And I specify an environment variable that says what my training script is. So I can build this container, and in this example that I'll make available to you, shows you how to build this container and then create a Elastic Container Registry, EC2 container registry, and then push your image to this container registry. So rather than bring your scripts, you can build and push this container to a registry. And for the rest of the workflow, instead of providing your training script, you just provide the link to this particular container that you push to your registry, and everything else works just as expected. Okay, that brings us to the end of both the demos, and we'll do a quick recap. So if you're an existing Kubernetes user, or you want to standardize on Kubernetes, or you're starting to explore Kubernetes, but you want to leverage all the innovations and new capabilities that are machine learning specific in Amazon SageMaker, there are a couple of ways to do this. If you're a Kubeflow user, you like to write Python code, and you're a data scientist, and you use Kubeflow pipelines, you can now use Amazon SageMaker components for Kubeflow pipelines and make SageMaker capabilities be part of steps in your pipeline. So you can mix and match components that are your custom containers running on Kubernetes, and mix them with SageMaker services that are unique to SageMaker. Say you want manage Spot instances training to save costs, you can do that by adding a component that runs on SageMaker. The second way to use Amazon SageMaker capabilities in Kubernetes is to use SageMaker operators for Kubernetes, which gives you a more native Kubernetes experience. This is particularly useful if you have some IT or operations expertise, or you are familiar with writing YAML specification files for Kubernetes. Then you can write it here, and you can write them and use the operators. And the best part is, because they're all declarative in YAML specification files, you can integrate them into your CI/CD pipeline and get automation and so on. Here's some more resources, the 2 blog posts I mentioned right up on top. We also have a workshop, eksworkshop.com, that covers everything there is in EKS. There's a section on Kubeflow and pipelines. Be sure to check it out as well. Of course, there's a Kubeflow documentation on how to set up and use Kubeflow on AWS. That's on the official Kubeflow website. And with that, I will stop and say thank you for listening to me. If you have questions right now, I'm happy to answer them. If you have questions tomorrow, day after, a week from now, or a month from now, I'm still happy to answer them. There are different ways you can reach out to me. The best and the quickest way is on Twitter, but there are also other channels. I also write articles on Medium and AWS blogs, so be sure to check them out. I'll stop here and now take your questions. Thank you for listening.